Good afternoon, everyone. Thanks for coming. So I'm assuming there are non-French speaking person in the room. Who does not speak French? Okay, so I will speak in English, or do my best to speak in English. So my name is Frédéric Beau. I work for EDF on codes and standards, on the development part of codes and standards, and on the implementation of these codes and standards in EDF projects. But today, I'm very pleased to give you this presentation on behalf of AFCEN, where I have a role as editorial committee chairman. So that's the development part of codes and standards. We'll be discussing today AFCEN codes and technical publication. I will give you a very brief overview of, or reminder for those who already know AFCEN, what AFCEN Association is, our products and services, our strategic plan and editorial committee, and that will bring me to a short description of the scope of AFCEN codes, and to guide you us into the editorial program, so that the program of work, the activities, and the topics that in the various codes that you can see on the right-hand side of the slide that are being developed at the moment and in the future. Okay, AFCEN Association in a nutshell really was created in 1980, so it's an old lady, more than 40 years old now. Of course, AFCEN is an abbreviation that stands for a French title, right? But now we'll just name it AFCEN to make it simple. It's an association, it's a society, an institute, if you will, that whose purpose is to set out rules for design and construction of nuclear island components, I should say structures, systems, and components, as we will see later. And this association brings together about 70 company members that are experts delegated by these 76 company members as we speak today. And globally, we are talking several hundreds of experts working part-time, most of the time, for AFCEN, and in the various committees that we'll shortly describe. So that's a picture of where AFCEN members are from. So no wonder most of them are still based in France, but sometimes and very often with activities outside of France. So that's the bottom of the picture, is all the French-based companies. But beyond France, of course, Europe is our main, the main area where we develop our activities, and we have a few other members, in particular from China or from the US, member of our association. And this is also a very simplified view of where AFCEN codes have been used, either partly or in full scope. Obviously, again, you can see 56 is the number of power plant in operation in France that are based on AFCEN codes since the 1980s. 3 in blue, just next to France, is the number of units being constructed as we speak. And so the large numbers you can see in China, 42, I think, is the number of units in operation based on AFCEN codes. And again, that takes us back to the 1990s and early 2000s. So a few figures, and then we come to our products. So very basically, our products, first is the AFCEN codes, and we will detail the scope of AFCEN codes a little bit later and their program of work. So that comprises 7 codes covering the main structure, systems, and components of nuclear power plants, but having a nuclear safety function, that's important. So mechanical components, civil structures, electrical and INC components, fuel components as well, and fire protection. Most of them for pressurized water reactors, but one of them, the RCC Marex, for mechanical component for advanced reactors, high temperatures, fast breeders, experimental or even fusion reactors. And these codes are complemented by a set of guides, which we call a PETAN. So you have to get used and familiar with this name, PETAN. And these guides provide complementary or alternative rules to the codes. And we'll see later a couple of examples. That's just a view of when you log in the AFCEN website. That's what you will see. So what can you do on the AFCEN website? First, you can shop online. You can order our products, but you can also turn to AFNOR. AFNOR is distributing our products as well. But of course, you can reach us and contact us to join. Then you can also get information and connection with training partners that deliver training on our codes. And that's all listed on the website. And on the bottom part, very important, either you're a member or not, or you're a user, or you have 3 ways to interact with AFCEN. The first one, request for modifications. So you have a clear idea about what change you would like to see in one of our codes. So you just fill in the form and send it to the appropriate subcommittee. So one of the codes that I mentioned. Request for interpretations. You are not sure about a requirement or a rule in the code, so you just propose how you understand it, and AFCEN will tell you whether or not it's the right interpretation. And then there is a last form, user experience, we've named it, just for you to give your feedback when using a code, or it could be an open question, etc. So important, don't hesitate to use these tools to interact with us. Okay, a few words about our strategic plan that has been reworked in 2021. So as I said, our main mission is to provide codes, develop and provide codes and reference documents, famous PETAN, describing the rules for design, construction and in-service inspection of structures and components. Really our field is really very centered on Europe, because we have we reference a lot the European standards typically, and we have several examples, first and foremost in France, obviously, but of project development in Europe. So really our ambition is really focused towards Europe. Our values expertise comes first, obviously, because we are just an institute with experts sharing their knowledge and understanding and discussing and coming to a consensus about the rules to be used in the industry. It's important to mention that the main drivers is nuclear safety. Nuclear safety is a priority, but we also need to consider efficiency of the industry. So this is a balance to be discussed and agreed to come up with requirements and rules. And all these experts, obviously, they come to AFCEN to collaborate together. So there are 3 main challenges in our strategic plan. The first one is about the editorial policy for codes, and I will develop further in the next slides. A second challenge is about interacting with our stakeholders. We need to be even more recognized and known by prospects, regulators or suppliers. And again, our main target is really the European landscape. And the third challenge is about the knowledge in our codes and the ability to use them properly. And that's very much in relation with the training that we or partners of AFCEN are providing. But all these challenges cannot be overcome without as many resources as possible, expertise from all the industry. So this is just a call to all of you and to the WNE exhibition to join AFCEN. So the more, the better for our rules. To have efficient, practicable, and safe rules for our power plants. So regarding the editorial policy, we really need, the challenge is really about clarifying the content, the intent, and the deadlines to further develop our codes and technical publications. To do so, we need to consider a number of things, but most important is the experience feedback loop. So again, this cannot be done without the support from everyone in the industry. So we need the participation of key business experts, and we need also to be proactive and go to our main clients, the projects, or the main users, the suppliers and the manufacturers, to come to them and ask about their need and their experience. And that's all the idea. So all our committees work with that objective in mind. So let's go now a little bit in more details into the codes. Just to mention, and we'll see later, we'll detail a little bit the scope of this code, so what kind of structures or components they cover, what kind of activities they cover. But you will still find out that they constitute a consistent set of technical rules from design to construction and in service for this SSCs. So let's start with the RCC CW code, whose scope of application is really for civil structures that have a nuclear safety function. And the code covers all parts of the civil structures, from the geotechnical works to the buildings, concrete, reinforced concrete, or pre-stressed concrete for the containment building, the metallic liner for lightness of the containment building or fuel pools, all type of structural steel work, nuclear safety classified steel work, and the components in the civil works, such as anchors, joints, coatings, and paints. Activities covered go from design up to construction, and now our codes include also chapters dedicated to aging management of the civil structures, and all this to serve safety, serviceability, and durability of these components. Okay, the RCCM code, maybe it's one of the most famous code in our suite. RCCM code covers mechanical components of pressurized water reactors nuclear island. But mechanical components, we are mainly talking pressure equipment or parts attached or included in this pressure equipment. 3 levels of quality, as usual, and parts attached or inside this equipment include vessel internals, supports, also other equipment like storage tanks, beyond the piping, vessels, and heat exchangers, pumps, and also containment penetrations. Activities covered go from the design, its sizing and stress reports, the materials, how you choose the materials, the specifications to procure parts and products, and fabrication and control processes and methods, and all the rules to qualify these processes and methods, and all the documentation parts. So it's really a comprehensive guide to construct, that is design and build such pressure equipment. RSCM code is the companion code, if you will, to the RCCM in a way, because it deals with in-service inspection of roughly the same scope of mechanical equipment as the RCCM. So again, vessel piping valves, pumps, storage tanks, and all associated spare parts. During in-service, also it starts with the pre-service inspections, and it covers up to maintenance, that is repair, modifications, replacement, and how to install them on an existing plant. Oops. So the last, that's another mechanical code, if you will, but it is very specifically with the nuclear fuel components. So the fuel assemblies with its fuel rods and fuel pellets inside, but also the control cluster assemblies, rod cluster control assemblies, sorry. And similarly as for the other mechanical equipment, it covers design up to manufacturing and inspection of these components. But also interesting to mention, it also deals with the requirements for handling the fuel and transporting and storing them. Okay, let's change now a little bit of discipline. And this is electrical and automation, instrumentation and control. Again, for safety classified system or systems that could have an impact on safety classified systems. And so you have parts in the code dealing with the how to design the architecture of electrical systems, or the architecture of INC systems, and other parts dedicated to how to procure, build, and qualify electrical or INC equipment. Qualification meaning that rules to demonstrate that your equipment will fulfill their functions even during accidental conditions. And there is a dedicated volume on how to lay out these systems and equipment, considering all kinds of hazards, internal, external hazards, or common cause failures. And also a part dedicated on inspection and test method for this equipment. Also important to mention that the RCC manages the preservation of qualification for this equipment during the lifetime of the plant. The next one is the code on fire protection, applying to buildings with a nuclear safety function or hosting nuclear safety classified equipment. So the code will give you principles for nuclear safety regarding the fire hazard. Will give you a basis to design the fire protection systems in your building. Oops. And also provisions to lay out the buildings. And most important, it's really a guide to take you through the assessment of the fire hazard. RCCM-RX are very special code for mechanical components of advanced reactors, so far used for fast breeders, sodium-cooled fast reactors, research reactors like Jules Horowitz reactors, and fusion reactors. Parts of ITER are using the RCCM-RX. And again, in the same way as the RCCM, it covers from design to fabrication, including welding, of course. So that's a brief description of the scope for this AFCEN 7 codes, just to show that the benefit of having them managed inside one association is that it will provide consistency across the code and better manage the technical interfaces. And that's all. I need to move on. A couple of examples of AFCEN technical guides that are complementary to the code. Some guides will give you more in-depth understanding of the background of the code or of their evolutions over time, because we are publishing revisions of the code every 2 or 3 years, basically. So it's important that we explain about the modifications, the changes introduced. Or other guides will give you requirements, typically a very recent guide published last year, I believe, or early this year, on cybersecurity for electrical and INC systems. There are quite a number of guides regarding the application of the infamous nuclear pressure equipment regulation in France, ESPN. And other guides to help you introduce a new material or help you define the right seismic isolation approach for your nuclear facilities, for example. So the editorial program, and I'm afraid I'm a little bit short of time, just to mention that we have recently published for our members and our main stakeholders our second editorial program, starting this year until 2026. And in this program, there are a number of topics, all categorized into the 5 categories here mentioned at the bottom of the slide. First, we need to answer the needs of our users. As I mentioned earlier, we need to take most of the operational experience into account. We have also a driver towards introducing innovative practices in the code. Always a look at what's happening in the standards and regulation space to, as much as possible, align or conform with these regulations and standards. And a couple of actions regarding the improvement of our editorial, the way we write our codes. So very few examples on the fuel, the RCCC code for fuel assemblies. For instance, our users still need to have a better, some clarification regarding requirements on rules for the fuel components when outside of the nuclear steam supply system, when they are being transported or stored. And also we aim at introducing a reference system to allow for the introduction of special products, innovative products inside a commercial PWR, just to support this testing. Regarding the civil work, what I could highlight is our users express the need to have further optimized nonlinear methodologies for geotechnics, the determination of actions from the soil and the soil structure interactions. But we also recognize that we have still progress to make regarding the rules for the liners, and that's based from the operational experience from our various projects. We also aim at developing a dedicated chapter for coastal structures, also based on the experience feedback from Hinkley Point project in the UK. We are still further developing our aging management chapters, and also most important in terms of innovations, we will be soon drafting a guide for steel concrete structures. That's really a key challenge for in particular SMRs. Regarding RCC topics, there are still discussions to further develop the list of hazards to be taken into account when designing and qualifying electrical and I&C systems and equipment. And also, we've recently performed a comparison study between RCC and the IEEE standards. And as we speak, we're still thinking about what could be introduced or changed in the code to, as much as possible, bridge the gap with these standards, or just recognize that there is a difference and we are comfortable with these differences. In terms of fire, in the next edition, so we mean to introduce other types of impacts of the fire, typically regarding environment, or other types of actions that are related to the risk of fire. Important to mention that in the RCCF there are appendices to manage fire regulations in France and in the UK. You all know that these fire regulations are very specific from one country to another, and it's important that we take this into account and combine them with the requirements for nuclear safety. RCCM, there are quite a long list of topics because it's a huge code. We're undergoing many developments. I could maybe very briefly mention number 2. We are just about to issue a technical publication for the rules for low pressure and low safety class piping. We have a lot of operational experience to take into account regarding welding, local heat treatment, and important to mention also qualification of active mechanical components, pumps, valves. So there is a dedicated section in the code for qualification of equipment. And in terms of innovative topics, there are quite a few in terms for the non-destructive testing methods, or the advanced manufacturing process, additive manufacturing, or hot isostatic pressure. And again, we still have a line of work regarding the ESPN regulations. Same goes actually for the RSEM, a lot to do with the ESPN regulation. But ESPN, we are also trying to have it adopted and adapted to the UK for the operation of the EPR reactors in the UK. And similarly, as for the RCCM, some challenges regarding the introduction of novel non-destructive techniques, also techniques for repairing welds during operation, in operation. And the RCCM-RX has a lot to hear from application in the ITER, Jolorowicz, or MIRA project, still ongoing. Important to mention also, the RCCM-RX has issued a guide for how to introduce a new material in the code, and that will be further updated. And the RCCM-RX is very closely working in association with European R&D programs, and is happy to take all their output in consideration. Okay, so I understand we will meet in the room just next to the workshop. We're happy to discuss, and in particular my last 2 slides were about technical interfaces between codes, so that we can discuss. Also transverse objectives that all of our codes are doing their best to achieve. Thank you very much.